Welcome to March 20th LeetCode Challenge. Search in rotated sorted array 2. There's an integer array num sorted in non-decreasing order, not necessarily with distinct values. Before being passed into your function, nums is rotated in an unknown pivot index k, where k is greater than or equal to 0, but less than or equal to the length of the nums array, such that the resulting array is nums at index k, nums at index k plus 1, all the way to nums at index n minus 1, nums at index 0, nums at index 1, all the way to nums at index k minus 1, index at 0, or 0 index I should say. For example, we have the following array here. It might be rotated at index 5, pivot index 5, to become as such. So notice that index 5 is 0, 1, 2, 3, 4, 5. Everything at this index is pivoted, right? So 0 becomes there, and then everything gets swapped around. Or rotated, I should say, at the pivot. Given the array nums after the rotation and integer target, return true if the target is in nums, false otherwise if it's not in nums. You must decrease the overall operation steps as much as possible. So we have the following. We want to find target 0. We want to know if 0 is inside nums or not. The answer is true because it is. And then we want to find whether target is true or not, 3 or not. And this one is false because 3 is not in nums. So given the number of constraints here, we have length of nums being 1 to 5,000. Between those two, the index between is negative 10 to the 4 to 10 to the 4. Nums is guaranteed to be rotated at some pivot point. And targets between negative 10 to the 4 to 10 to the 4. Similar to this approach, we have another question here, but nums may be duplicates. Would this affect the runtime complexity? How and why? So obviously, if we just ignore the pivot rotation stuff, we're just asking the simple question is target inside nums? Right? In order to do that, we just basically do binary search we did a while ago, or we just do a linear sort right here. So for num in nums, so we iterate through each element in nums. If num equals target, return true. Otherwise, return false if it's not in nums. And let's run that. So this is a straight up linear search. Let's see if this works. Overall, yeah, big O n time complexity or run complexity is not the best search algorithm. Compared to, well, I mean, you could probably do any type of search algorithm that's not linear time, and that will work as well. But I mean, it's short enough to cover this question. Memory usage is big O of constant, memory, constant space, because we use return boolean. Alright, there's better ways to improve this question, but that's pretty much it for this one. Alright, have a great day, guys.